In order to answer this question, we are going to have to conserve angular momentum. So that means that the initial angular momentum has to be equal to the final angular momentum. And angular momentum is equal to the moment of inertia times the angular velocity. So the initial moment of inertia times angular velocity is equal to the final moment of inertia times angular velocity. And what we want to solve for is the ratio of the final divided by the initial angular velocities. So to solve for that, we would need to divide both sides by the initial angular velocity, and so it cancels on this side. Then to get this ratio all by itself, we also need to divide both sides by the final moment of inertia, so that it cancels over here. So the ratio of the final angular velocity to the initial angular velocity is equal to the ratio of the initial angular momentum divided by the final moment of inertia. So the initial moment of inertia divided by the final moment of inertia. The initial moment of inertia is just due to the first disk, the disk that has moment of inertia I1. So the initial moment of inertia is just from that first disk. The final moment of inertia is due to both disks rotating. So that would be I1 plus I2. And so the option we would want to select for this ratio is I1 divided by I1 plus I2.